Hey everyone, you're Smith Deepak. So today we'll be looking into this very popular question, that is chocolate distribution problem. So we'll be solving this question in this Geeks for Geeks platform. So firstly we'll be looking into the question, we'll understand the question. So then we'll just look at how we can approach this then, and then we'll code it. So firstly, that it's very important that one should understand the question before jumping into the coding. So here the what we have given to us, that is we have given an array named as this a, and which is having positive integers of size n. So here array is we have array of size n, means length is n, means there will be n number of elements. So here where each value represents a number of chocolates in a packet. Okay, we'll just looking into that in just a time. So here we'll just firstly see the question. So here each packet can have a variable number of chocolates. Okay, so there are m students. So what does it mean? So here we have an array of length n means n number of elements are there. So that elements denotes what? So here we have packets of chocolates, and each packet there is a so there are various number of chocolates. Means it is not fixed that any chocolate there in each packet there will be 10 chocolates only. There can be any number of chocolates. We'll be just looking into that with this example and all the stuff. So here this line is saying that all that stuff only. So here there are m students. Okay, the task is to distribute chocolate packets among m students. So here we have m students, we have to distribute that chocolates, whatever chocolates we have in this area, we have to distribute to this m students. But there are certain conditions that each student gets exactly one packet. It should not be the case that let's say there are 5 students and 4 students are getting chocolates, but there's only a single student that who is not getting even a single chocolate. So that's unfair. So that should not be the case here. So here each student gets exactly one packet, at least one packet. It has he or she has to be with him. Okay, so here, and the second condition that should follow, that this both condition has to be followed, not either this two both condition has to follow. So the second condition is what? So here the difference between maximum number of chocolates given to a particular student and the minimum number of chocolates given to a student is minimum. So what does this line says? We just look into that. So we have understood this much. Okay, we'll just look into that. It's a very trickier line, trickier constraint we have provided. So here input is what? Let's say there are 8 elements, means n is what? Length of array, means we have 8 packets of chocolates and m number of students. Here 5, we have 8 packets of chocolates and 5 students, means we have to distribute these chocolates with these five students. So here these are the packets of chocolates. So here in first packet there are 3 chocolates, in second packet there are 4 chocolates, in third packet there are 1 chocolate, in fourth packet there is 9 chocolates. So as you can see here, the number of chocolates vary in each packets. So here in this packet there is 56 chocolates, in this packet there is 7 chocolates, in this packet there is 9 chocolates, in this last 8 packet there is 12 chocolates. So how will we distribute? So output is 6, but how we are getting this? So explanation is that the minimum difference between maximum chocolates and minimum chocolates is 9 minus 3. So it's a you will not understand. So let's say we are taking here, we have various examples. So let's say, so here, okay, so we'll just take this example. So here we have this array of chocolates. So here what will I do? So here I have to distribute these chocolates with m number of students. Here m is what? 5. So let's say, so here, okay, so here let's say firstly I will just try to give this for starting 5 chocolates. Okay, starting 5 chocolates this to all that 5 students. So here what is happening, that let's say I'm giving this chocolates to the first student, this chocolate to the second student, this chocolate to the third student, and this to the fourth, and this to the fifth student. So here what is, I have to check what, that whatever the last student chocolate, so whatever amount of chocolate that last student is getting is what? 56. Last student is getting 56 chocolates and the first student is getting only 1 chocolate. So what do I have to do? Means we have to distribute chocolates in such a way that there should not be unfair among that students. means we have to so here 50, maximum number of chocolates we are providing is 56 and minimum is 1. So we have to distribute in such a way that the difference between should get decreased. Okay, so here let's say this fifth student is getting 56 chocolates and the first student is getting only one chocolate, so that first student will think that I'm getting only one chocolate and this fifth student is getting 56 chocolates, means fifth student have 55 chocolates means extra than me. So if let's say this first student is getting 20 chocolates, okay, and here it is getting 56 chocolates only, so here first student will think that that fifth student is getting 56 chocolates and I'm getting 20 chocolates, means fifth student have 36 chocolates more. So here as you can see that unfairness is getting decreased. As you can see, means yeah, still unfairness is there, but it is getting decreased. So we have to find the gap between this so gap between this, let's say, so here 56 chocolates and one chocolate, so here 56, so here as you can see, okay, so the gap between, so here 56 minus 1 is how much, that is 55. So if let's say here 56 chocolates is there, okay, so 56 chocolates and the first students get 20 chocolates, so here that the gap is getting decreased, so you reduce, so 36 is there. So we have to do this only in this problem. So here we are asked to do that only. So whatever we discussed here, that this first that this line is saying, this line is saying that this line. So here we got, so this line also, that second, the difference between maximum number of chocolates, here we have that 56, and the minimum number of chocolates, that is that first one, has to be minimum. See here, has to be minimum, means what we are finding that, let's say this, okay, what we are trying to find that this 3 and this we have 5, these are this in under this we have, my space is this only. So here in this particular window, what is my maximum element and what is my minimum element, we are finding that, and the gap between I have to reduce as far as it is possible. We have to do this only in this in this question. So it's a simple task, we'll just go through it. If you'll just solve that example, then it will be much more clear to us. So as you can see, 9 minus 3, it's a minimum gap which we are getting in this. So we'll just check it, verify it with the by dry running this. So here what we are doing, we are using here window, so it's a window method. So here we'll be using window. So here let's say firstly so here I have only 5 number of students, m equals to 5, so we'll be distributing this number of chocolates, whatever number of chocolates packets I have, to just 5 students only. So here I'll be making windows of 5 students. So let's say I am distributing to this number of this packets to that 5 students. So here minimum is what, so here as you can see that minimum, okay, so here minimum is what, minimum is 1 and maximum is 56. So for finding this minimum maximum, we have to again search in this, what is my minimum, what is my maximum. So there will be again n complexity, so it will be time consuming. So what we'll do, we'll just simply sort it, so it will be much more easier for calculation also, and our time complexity will also decrease. So that's why we are just sorting it before finding whatever minimum, whatever maximum, whatever in what number of chocolates packets we are putting that window. We'll just firstly sort it. So let's say after sorting, let's say I have this, okay, so 1 3, then this 4 will come, cool, and then this 7 will come, and then we have 2 9, and then we have 12, and then we have 56, cool. So these 8 elements we have, 1 2 3 4 5 6 7 8, okay, these 8 elements we have here. So here firstly let's say my window is here with okay, so my window is this much, 1 2 3 4 5 5 packets of chocolates I have here for distributing with the 5 m number of students. Okay, so here first student is getting one packet of chocolate, one chocolate means packet of chocolate. In that there is only one chocolate, and the fifth student is getting the largest maximum number of chocolates, because in this packet there is 9 chocolates. So here what we are concluding that is that here we have minimum number of chocolates in this particular window. In this particular window only, how many chocolates does we have? Do we have? So here 1, and what is the maximum is 9. So what is the gap between it? Gap between it is will again I will one more. So here, and gap will be what? Gap is what? 9 minus 1 is what? 8. So a gap between this is 8. So a gap between this is 8. Okay, cool. So okay, we found this 8. Okay, so initially let's say I don't know what is the gap. So initially we'll take gap value has any maximum value, because we have to find minimum number of minimum value of gap. So initially let's say I don't know, I'll just take the maximum value of integer has my answer value and has my answer. Okay, so now 8 is there. Okay, now that's okay, the gap is 8, because this is also an optimal answer, because I'm not knowing that whether I will get further, I can whether I am able to reduce it further or not. I will just store it here in this gap variable, that yeah, the gap between this is 8. What will I do here is that now I'll just shift my window here. I'll just shift my window like this. Now my window is this. So now you will say that why we are considering that all these 5 elements in this window, whatever elements I have, that are consecutive only. If you will just take like this, okay, so let's say here you are taking this 4 element and this element. So here as you can see, these are arrays sorted. So here it is 9 is smaller than 12. So if when I will just find the gap between this 9 minus 1, it will be 8. And here the element out of which are not so here 12 is not a consecutive element. So here it will be greater than all these elements which is present in this window. So here 12 minus 1 will be 11, which is not an optimum answer. So here that's why we have to consider all the elements in the consecutive position. So that's why we are taking, as you can see, this 1 3 4 7 9, and not like this 1 3 from here, 7 9 from here, and then 56 from here. It is not the case here. We have to take all that 5 elements in the consecutive, that should be in the consecutive location. So here that's okay. So yeah, so here as you can see, okay, so here let's say my second window, I will be starting from here, this 5. So the minimum of the in this window is what? Minimum in this window is what? Okay, so the now my minimum here is 3, maximum here is still 9. Okay, so the gap between them is what? Gap between them is what? So as you can see here, 9 minus 3 is what? Sorry, so here 9 minus 3 is what? 6. So here my gap values get reduced. So here now my 8 is getting reduced. So here I'm updating my 8 with 6, because 6 is smaller than 8. If let's say I'm getting gap between them as 10 or something, or some value which is greater than 8, then in that case I will not update. I will update my gap value only when I will check whether this particular gap value which I'm getting from this window is smaller than whatever value I already have. Then only I will update my gap value. So here in this case I am updating 8 with 8 by 6. Okay, that's cool. So we'll again check for the next window. Okay, so here I'll be again checking for the next window. Okay, so here my next window will start from this to this. So you can see here 4, 7, 9, 9, 12 is all this number of chocolate packets are there in the next window. So here minimum is what? Minimum is 4, and maximum is what? Maximum is this one, 12. So now I will check whether the difference between this means the gap between this is smaller or greater than 6. So here I have 12 minus 4, so it's 8. So here 8, I get 8 here. So here now 6 is smaller than 8. So it doesn't make any sense that I will update 6 by 8, because it is 8 is greater than 6. So here in this case I will not update my gap value, so I'll let it be 6 only. So here I will check for the next possible answer. So here I'll just shift my window. Okay, so here I'll shift my window. So my window will be from here to here. So okay, so here from this to this is my window now. 7, 9, 9, 12, 5, all these elements are in my next window. So here in this case my smaller element here is, you can see yes, okay, so yes, these all elements, okay, sorry, I did wrong. So here these all elements are there in my next window, 7, 9, 9, 12 and 56. So here I will check what is my smaller element. Here in this case is 7, and what is my maximum element is 56. Okay, so what is the difference between them? 56 minus 7 is what? 49. So here I'm getting gap value has 49. I will check whether this 49 is smaller than 6 or not. So here I found that it is not smaller than 6, so there is no need to update 6 by 49. So let it be 6 only. So here my gap value is 6 only. So here I will again check for the next window. Okay, cool, I'll check for next window. So here 9, first element, second element, third element, fourth element, but here I don't have fifth element, because here I have to distribute chocolates with m number of students, and here m is 5, but here I'm not having that much number of elements. So there is no more further, I can't make another window. So here we can make only how much window? 1. So here as you can see I'm making here how much window? Only 1, 2, 3, 4 and 5 number of windows. Sorry, 4 number of windows only. Here only 4 number of windows are possible. This and this and this. Okay, so here let's say this number of windows, I'll keep a count of these windows. So let's say I is the counter, means it will count that up to what I should go. So here it will start, it's okay, it is obvious that it will start from 0, because indexing starts from 0 only. But what will be the end of this? Okay, so here, so as you can see here in this particular, you can see here this, in this window, from this to this window, as you can see 1, 2, 3, 4, 5, this window from 1 to 9. So here first element is at 0th index. What is that is I only, means first value, first element is at ith position, that is I equals to 0, and the last element will be where? That will be, so here my n length is what? 8. So how will I find that last element? Because here my last element is not this, my last element is this 9 only. So here how will I find this? So here in this case, as you can see, okay, just a second. So here I have only m number of students, m number, so window size will also be m only. See, a window size is m only, 5, 5, 5, 5. So we'll just subtract n minus m. It's how much? 8 minus 5 is how much? 8 minus 5 is 3. Yeah, it's 3. So miss the first window size will be up to 3 only. Will up to 3 only. As you can see. That's cool. Okay, 3 means it's an index value. So here you can see 0, 1, 2, 3. Okay, so we'll just jump into here. Okay, sorry. Okay, where was I? So here, sorry, it is saying, so here as you can see, means it is saying that how many number of windows I will have. So it is saying that, okay, 0, 1, 2, 3, this much window I will have, which means I will have 4 window. This first window, this you can see here, this first window, this second window, this third window, and then lastly this fourth window. This much window is possible. There is only 4 windows possible, as you can see here. So see here, firstly, okay, let's say here, okay, there is only 4 number of windows that is possible. Okay, so here you found that. But what is this value? This index will be what? So here the length of this is m, because there is only 5 elements. So here length is 5. So the last element will be at m minus 1, because indexing is start from 0. So here m minus 1 is what? 4. Yeah, so as you can see, 1 is at 0th index, 3 is at 1 index, 4 is at 2 index, 7 is at 3 index, and 9 is at 4 index. So here the last element is at m minus 1 position, and the first element is at ith position, I equals to 0. Okay, that's cool. So here for finding that last element, what will I do? Here I can conclude that the last element will be at m minus 1. But here, if you will see here, in this case, I'll just make it, it is just a second here. So you have 1, 3, 4, 7, 9, 9. So as you can see, 1, 3, 4, 7, 9, 9, and now we have 12 and 56. Okay, so here my second window is from where to where. So here my second window, okay, see here. So here my second window is from 3, 4, 7, 9, and this. So okay, so here is my second window. So here I plus plus, so here I will update from 0 to 1. Okay, so I know the position of first element, because it is a position of I only. See here, I is now 1, so first element is at 1. But what is the position of last element? Because I have to find, so because here we have to find minimum and maximum. So I can directly find without any calculation that at the first position there is a minimum value, and at the last position there is the maximum value element. So I can directly find minimum and maximum. So here I know the minimum, that is the first element, that is ith value, I equals to 1. See here, 1. But how will I find that the position of last element? So here just now we found that it is of m length. So my last element will be at m minus 1 position. Okay, that is 5 minus 1, which is 4th position. So here 0, 1, 2, 3, 4, as you can see, but it is not at 4th position, it is at 5th position. So what should I do? I should add this ith value, because I value is 1. I should add it. Yeah, I should add it. So here 1 plus 5 minus 1 is how much? So here 1 plus 4, which is 5. So as you can see here, last element is at fifth index. Okay, so in the same order, if you just see here for the next window, that is my third window. It was all about the second window. So if you will just see here for the third window, okay, so here is, let's say, third window, that is starting from 4, 7, 9, 9 and 12. So here in this case my I will again update, that is, okay, 0 was there, that was get updated to 1, now it is getting updated to 2, because here we are doing I plus plus. Okay, so here in this case it is 2. So here 0, 1, 2. Yeah, here is my I, that is first element, or also my minimum element, and the maximum element is at the last index of this window, and the window size is 5. I know that it is at the m minus 1 position. So here 1, 2, 3, 4, 5, m minus 1 position. So just now we have formulated that formula that I have to add, because m minus 1 is what, because for the all the windows, so here see windows is getting changing, it at each iteration the window is getting shift. See here, from, see here, first element in the first window, first element was there, but at the second window the first element was not there. At the third window, second element is not there. So it is that last element is also getting change, and the first element is also get changed. So here my first element, I know that is it at the ith index, that is my first element, that is minimum, but the last element, that is my maximum, is at m minus 1 position, that is also I know. But here my windows get sizes, but window location is getting changed, so here I'll just keep on adding this I plus. So here m minus I is what, 2, plus m minus 1 is what, 5 minus 1, 4, so it is 6. So as you can see, 0, 1, 2, 3, 4, 5, 6, we are getting my last element, that is my max element. So yeah, my minimum will be at ith position, and my maximum will be at that last position, that is I plus m minus 1, this formula, this one. Okay, and my minimum will be at ith position. That's okay, my minimum will be at ith position, and my maximum will be at I plus m minus 1 position. I think it's clear. So we'll just jump into the coding part. Okay, so here as you can see, so firstly as you can see here, I don't know my answer. So because I have to find here what, firstly means I have to find what, I have to find this. As you can see here, at the last we found gap has this 6, and here also as you can verify that our output is this 6, that means our solution is correct. So we'll just code it. So here firstly I don't know my answer, so what will I do? Okay, so here I don't know my answer, so what will I do here is that my answer, okay, my answer I don't know, I have to find a minimum answer. So I have to assume that initially my answer is the max answer. Okay, so I'll just add the maximum value of integer. Okay, so now what do I have to do? We saw that here firstly I have to sort my array. Okay, so here array name is nums, so I'll just quickly sort it using that collections method. So here collections dot sort will just quickly sort it, and my array is nums, so it is sorted. So here my that iteration will be from where to where, means how many number of windows will be there. So here number of windows will be how much, number of windows is how much. So here in this case number of windows is 4, but how did we find that? As you can see, this one I will be this case, this So here my initially my first window, second window, third window, fourth window, like this way. So here until I, so here my first window will be I'll start iteration counter, my ith iter counter from 0, but I will not go till the last element. I have to go until I am getting 5 number of elements in my window. So how will I find this last value? Okay, so how to find that? So here my length of element array is 8. So but we am not getting I'm not going till the last element, that is 8. I am going till the mth element, means the fifth element. So here I have to do n minus 1 in so here 3. So I'll go from 0 until it is less than equals to 3. So means I will not write 0 and 3. Yeah, initially it will be 0, but the ending condition is not 3, it is n minus 1. I have to do n minus 1 here. Okay, n minus 1. So here so there will be, okay, so here I'll just write a for loop for iterating that number of windows. So here my I will start from 0 and it will be end with when n minus m is until m minus m is there. But here I have to do equals to also, then only it will count index value. Means here if you will just count 0, n minus 1 is what, let's say n is 8 and m is 5, 8 minus 5 3. So if I'll just write here type here less than, so here it will iterate how many times, 0 1 2 3. Sorry, not, it will not go till 3 because it is there is no equals to. So that's why we have to add equals to also here. That's okay, and I have to just do increment part. Okay, so here now I have to find minimum and maximum. Okay, so here what is my minimum? What is my minimum here? Minimum is the first element of my window, and the first element of my window is what? Is I. Just now we saw here the first element of my window is I. See here, first element of my window is I, and that is the minimum, and the maximum element, that means the last element is the maximum element at what position? At I plus m minus 1 position. Okay, that's cool. So here my max is at, okay, so here my max is at I plus n minus m. That's cool. And now I have to find gap between this. So here I have to find gap between max and minimum. So here I'll just do max minus minimum, and now here I have to check whether my gap is less than my already having answer. This already answer whichever I answer I have, is this gap less than my answer? If it is less than, then only I will update my answer with by gap, or else I will not update it. And I'll just keep on doing this thing again and again repeat until the window is possible, that is this condition. And at the last I'll just simply return that my answer. So we'll just run it and let's see whether it is getting accepted. Yeah, so as you can see, compilation completed, means everything is working fine, as you can see. Cool. So we'll just try to submit it. So here its test case is getting processed. Also here it's giving me wrong answer. So we'll just check it again. So here I just sorted it. I'm iterating it, I equals 0, then I is less than n minus less than equals to n minus 1. Minimum is I, maximum is I plus n minus m. That's okay. And now gap is between the max and minimum, and if gap is less than answer, then answer equals to gap, and then I will just return my answer. Okay, so where the issue is, so let's say long, here it is the return type is long. So let's see that whether it is getting accepted or not. It's again giving a wrong answer. So the code's output is 23 and its correct output is 65. So is a huge difference. So yeah, here we have to not return index, we have to return the element. I have to check here element. Here we have to check element. Yeah, so here n minus m, and now I think it will get accepted. So it's saying okay. So here we are doing like this way, but here it is saying array list. So here for array list, the method, the writing, the for getting element is we get element like this way by writing dot get like this. So we'll just write this quickly, get I plus n minus 1, and now I think it's okay. So it's saying index 4 out of bounds for length 4. So here I is heading from 0 until I is less than equals to n minus 1. Okay, n minus 1, n minus m is what? 8 minus 5, 3. So 0, 1, 2, 3. Yeah, it will go equals to until equals to also. Okay. So here okay, so there's a type of mistake. So here the max element is at I plus m minus 1 position. By mistakenly another thing. So here it should be not this way, like it should be like this, I plus m minus 1. And yeah, now I think it will get accepted. Yeah, there are 100 test cases is passed out of 370. Now 190 test cases is passed out of 370, and yeah, all the 370 cases is passed. Okay, so your problems is solved successfully. So that was all about this problem. So make sure you subscribe, like, and comment on the video, and comment that on what problem the solution you want for the next video. So thanks for watching.